two cars leave the same location at the same time. One is going due east, the other due north. One is going at 60 kilometers per hour, the other one at 40 kilometers per hour. 2 hours in, what's that? 45. Thank you. That's going to make our math a lot easier than 40. 2 hours in, that would mean this guy will have traveled 90 kilometers and this one 120 kilometers. And we want to know how fast are they going away from each other? How fast are they separating? So we're wanting to find out the speed of that green line there when they're separating. So first of all, these are right-angled triangles. Notice, you recognize these triangles? Can you tell me, without doing too much math, how long the hypotenuse is on the second triangle? It is a 3, 4, 5 one. Can you see that it's a 3, 4, 5 triangle? Just a bigger one. If you think 3, 4, 5, you think 9, 12, 150. 9, 12, 15, so that'll be 150. Now we could use a squared plus b squared equals c squared. Sometimes people like to think of this as, since it's going up, we'll make that along the y and this along the x. And we could call this z, just so we have x squared plus y squared equals z squared. And what we're trying to find is dz dt, right? At 2 hours. We want to know how fast they're separating. So this is what we want to solve for. Okay? That tells us that that's a function of time. What do we know? We know dy dt is 45. dx dt is 60. And so y is also a function of time, and x is a function of time. We have three things this time. How are they related in a formula? Can you relate them in a formula? Yeah. You know that x squared plus y squared is equal to z squared. I should make my 2's prettier. Oh, then you can tell the difference between the 2 and the z. And we know at 2 hours what x is. We know at 2 hours what y is. We know at 2 hours what z is. So we can take the derivative with respect to time of this whole thing. So again, the hard part is coming up with what equation should I use that relates everything. And then once you have that, then you can take the derivative. So this will be 2x dx dt plus 2y dy dt. It's all implicit differentiation. Plus 2z dz dt. Do we have all the information to plug things in? Do we know x, y, and z? Do we know dx dt, dy dt? Because we want to find dz dt. Yes. Now something interesting is going to happen here. We're going to plug in x. X was 120. dx dt was 60. Y was 90. dy dt was 45. And 150 dz dt. Maybe you could see that you could divide all the 2's out if you wanted to earlier to make your equation a little bit simpler. Doing that math, you're going to get 75 kilometers per hour. Now, what's interesting about the answer is if we would go back to our speed triangle here, I'll call it, and just notice that this is also a 3, 4, 5 triangle. Can you see that if you take 3 and times it by 15, you get 45. 4 times 15 is 16. And if you took 5 times 15, you would get 75. So it makes you wonder, could I have just done that from the beginning, or is that just a coincidence in this example? Okay. The answer is, if you do have speeds going in a perfect right triangle in 2 different directions, you can always do a squared plus b squared equals c squared for the separating distance as well. Here is the proof of that. Notice that I'm going to take this equation here, right from there, because that's where we did our implicit differentiation. I'm going to get rid of the 2's already and just say I have x dx dt plus y dy dt equals z dz dt. Okay? Now, I want to show that I could do the a squared plus b squared equals c squared with those speeds for any time t. So I'm going to use any time t. And if I used any time t, then my distances all the way around, well, this one would be 45 times t. If t was 1, if we did t as 2, it would be 90, right? This one would be 60 times t. And a squared plus b squared equals c squared, you would solve for this one. This one would be 75 times t. If I took those and plugged those into here, here, and here, right, I'm going to get t, and the 45 is just another dx dt. So that would be dx dt squared. And then I'm going to get t, and then the 60 is just another dy dt. So I could write that as dy dt squared equals z times dz dt. And this z, whatever this speed is, will be proportional as well. So it'll be t times dz dt squared. And if you divided everything by t, you will prove that you could have done that from the beginning. So it's just kind of a neat application. Of course, this only works if the speeds are going in opposite directions all the way. We're going to be looking at some where one thing is fixed and one item is moving and not the other one. So we'll look at some examples like that.